Okay, this is part 2 of the ES10 Oceans video study guide. We were talking about ocean currents in part 1 and how they affect climate in coastal areas. There's another important thing to know about coastal areas and climate is that just the fact that a city is on the coast means that it's going to be milder than a city that is in the middle of the continent. The ocean itself, or any large body of water, is going to have a milding effect. That means that Boston, for example, is going to have cooler summers and warmer winters than you might expect based on its latitude. Topeka is going to have hot summers and cold winters because it doesn't get that milding effect of the ocean. It's not able to avoid the temperature extremes. And the reason why coastal areas or water has that effect on a city, or a location for that matter, is that water has a higher specific heat than land, and water avoids dramatic changes in its temperature. And that goes for a cup of water too. Water absorbs heat slowly and retains its heat well. So even though it's avoiding these dramatic changes, the ocean stores a lot of solar energy, the most solar energy. The ocean is called the largest reservoir of heat at Earth's surface. So, inland areas get really hot in the summer, really cold in the winter. Coastal areas are able to avoid these temperature extremes, and that's because of the specific heat of water. It avoids dramatic changes in temperature, and the ocean stores a lot of heat from the sun. So that's all pretty important. We're going to move on to some tides, which we covered in the astronomy unit. So tides are caused by gravity, the gravity of the sun and the moon. So this won't be drawn to scale. You've got the sun, and you got the earth, and you've got the moon. And the moon is orbiting around the earth, while the earth, oops, wrong direction. Earth is orbiting around the sun. When all three are lined up, either in the new moon phase or the full moon phase, you have a spring tide. When they are at a 90-degree angle from one another, sun, earth, moon, either in the first quarter or third quarter phase, then you have a neap tide. During a spring tide, your high tide is higher, and your low tide is lower. And that means there is a greater tidal range. In a neap tide, you have a smaller tidal range. So your high tide isn't as high and your low tide isn't as low. Another important topic for this unit is estuaries. So here's my not that greatly drawn Virginia. And Virginia is right next to the Chesapeake Bay. Virginia's 4 largest rivers flow into the Chesapeake Bay, so that part of Virginia is part of the Chesapeake Bay estuary. And estuaries are where salt water meets fresh water. That's H2O. You can't read that. Salt meets fresh H2O. So you have the salt water from the ocean meeting the fresh water from the rivers, creates what they call brackish water in the bay. It's salty mixed with fresh. The salt water is more dense, so it goes underneath the fresh water. And lots of fish like to hang out in this area, and lots of crabs. This is what you call high biological productivity. High biological productivity means there's lots of organisms around, lots of plants, lots of animals. And all estuaries are known for high biological productivity. It's also important to remember that any pollution from this part of Virginia is going to end up in the bay. But the Chesapeake Bay watershed is bigger than just that part of Virginia. It actually contains 6 states. So if you're polluting in New York, depending on where in New York you are, that pollution could also end up in the bay. So we depend on the ocean for a number of reasons, both environmental and economic. Humans depend on the ocean for oxygen. Remember that algae in the ocean provide 50% of the oxygen we breathe. People depend on the ocean for recreation, including tourism, industry like fishing and shipping, and also mineral resources. But humans can also harm the ocean as well. Humans can harm the ocean through point or non-point source pollution, trash dumping, oil spills, ocean acidification, which leads to coral bleaching. And we talked a bit in class about something called microplastics, which is plastics less than 5 millimeters long. That ends up from larger plastics that have broken down. So the ocean changes with depth. Anything at the surface is called pelagic. Anything at the bottom is called benthic. Even in a shallow area, if it's at the bottom, it's benthic. Light from the sun can only penetrate so far. The area where light penetrates well is called the photic zone. Then you have an area with very little light called the aphotic zone. And then you have the midnight zone, like down in a trench. Also, as you descend with depth, while light decreases, pressure increases. So light decreases, pressure increases as you go with depth. In the ocean, you have lots of itty-bitty organisms called algae or phytoplankton. They are constantly doing something called photosynthesis, using the sun's energy for their own, also taking carbon dioxide out of the atmosphere and putting oxygen back out. Eventually, the phytoplankton gets eaten by slightly larger predatory animals or herbivorous animals like zooplankton. The zooplankton might get eaten by some clams or a fish. It's like the food web. And then there's always a shark too. But all this stuff, when it dies, eventually goes to the bottom. If you're on the bottom of the ocean in an area with lots of critters, there's something called marine snow, and it's all the dead animals hitting the bottom, and that stores carbon dioxide or carbon. The ocean is a carbon sink, and that's a service that it also provides for us, because the less CO2 we have in the atmosphere, the less climate change is affecting us. So the ocean's pulling out carbon, that carbon's hitting the bottom, that's turning into rock. That's good for us. One last thing I'm going to squeeze in here is sea level rise. The oceans are rising. This is due to thermal expansion that is just expanding when it's heated, and melting ice from the ice caps and glaciers. Thermal expansion is more important than melting ice. Even though you think of melting ice first, thermal expansion actually causes greater sea level rise. And one last thing. Here is the shore. Here is the ocean. There's something called upwelling. You got a cold ocean current riding along the bottom because it's more dense. And when it rises up, that's called upwelling. And when it rises up, it also brings up a lot of debris, dead organisms basically, which feeds biological productivity at the surface. These fish are terrible, but you get the idea. Upwelling causes biological productivity, so both estuaries and areas with upwelling are known for being areas with lots of life. I think that about covers everything for the tests. Good luck.